Hey everyone, in this video we are gonna talk about perpendicular and parallel lines, plus we are gonna talk about ratios between two given lines. So if you're working on study island, what you're gonna need for this assignment is the distance formula, slope formula, uh, slope intercept form of an equation, of a linear equation, and then let me see. Those are gonna be pretty much what you're gonna need. So the first question over here gives us two lines, and then it says, given the two equations below, determine which statement best describes the graph of the equations. The reason I know that these are going to look like a line because the equations are linear, because the highest power of an x in here is just 1, x to the first power. Because there's no power over here, that means they are x to the first power. When that happens, we deal with a line. If we have x squared, we are dealing with a curve with just one turn. If we are dealing with x cubed in an equation, we are dealing with a curve with two turning points. Okay, so here, which statement describes the two graphs? Okay, the two lines are parallel. Let's see the options we have. They are parallel, they coincide, they intersect, they meet at a point but not with a 90 degrees angle, because that says not perpendicular. They are perpendicular. Now let's see if the lines don't touch each other. That means they don't touch at all. And for this, the slopes must be equal. The slope of the first line should be equal to the slope of the second line. Let's see if that's the case. So both of these equations are in the form of y equals mx plus b, which is the slope intercept form. In here, that number gives me the slope. Okay? So let's see if that number is the same for both equations. So this one here is 4 over 5. That one here is negative 5 over 4. They're not equal. They're not the same number with the same side, with the same sign. So A is not my answer because they are not parallel. If they were to be parallel, they would have had the same slopes. They would have had the same numbers in front of the x of both of the equations. The second option is they coincide. What that means, the equations are the same. Or when you have the same equations identical, it's going to be an idiot proof. Everyone is going to see that they're the same, right? So the other option is that when one of the equations is multiplied by a number. Here's an example. Y equals 2x minus 1. Let's say that's your first equation, okay? And then I'll multiply everything I see in here by 2. 2y equals 4x minus 2. So when you multiply all of the terms by any number, it could be a fraction, decimal, whole number, then both of those equations are gonna be the same line, exactly the same line. They're gonna be on top of each other. But in this case, we don't have that. So the two lines intersect but not perpendicular. They do intersect, but they are going to be perpendicular. Let me explain the reason. What this means is the slopes in here are 4 over 5 and negative 5 over 4. Slopes are negative reciprocal. If they are negative reciprocal, if the slopes are negative reciprocal, what happens is you flip the fraction or your slope and then change the sign. Here are some examples of negative reciprocal slopes. So the first example would be 1 over 2, flip it, turn it into 2 over 1, change the sign. It was positive and I turned it into negative. That's just one example. If one slope is 1 over 2 and the other one is negative 2, then you have perpendicular lines. So if you have negative 4 and this is -4 is -4 over 1. They're the same. I'm just putting it so we see how we are going to flip it. When you flip that fraction, it becomes 1 over 4. And then the originally it was negative. Change the sign into positive. That's just another example. Let me write a pair of equations. Y equals 3 over 7x plus 1. In this case, the slope is 3 over 7. If the second equation has negative, because the original was positive, flip it. X plus 1. That number doesn't matter. That number could be anything. The last number doesn't matter. The only thing that we do check is the slopes. If they are the same, the lines are perpendicular. If just the slopes are the same, the lines are perpendicular, and numbers should be different. If the slopes are negative reciprocal, that's not how you type. That's not how you type reciprocal. But that's not a problem. So, when the slopes are negative reciprocal, then you are dealing with 90 degrees perpendicular lines. When the equations are exactly the same, the lines on top of each other, they coincide. Yeah, that's all you need to know. So this one is going to be a D. Because the slopes are negative reciprocal with different numbers in the end, then they are perpendicular. So the second question. Which of the equations represent the perpendicular bisector of Wx graphed below? So we are looking for perpendicular bisector of this. Let me just scroll down just a little more. Okay. So the perpendicular bisector, what does that mean? Bisect means cut it in half. So it'll cut the whole thing right in the half. So cut in half. Perpendicular means 90 degrees. So I'm looking for another line that'll cut this in equal pieces with 90 degrees angle. So the first part, like the 90 degree, let me see. This part is easier, cut in half. What I will show you is a method, not the formal method. A formal method requires you to put the endpoints, the coordinates of this, and then apply the bisector formula, which means add the points, divide them by 2. I'm not going to do that. I'll show you a shorter method. So it'll work if you have a coordinate plane. So for this, what I will do is first I will count the vertical difference from point X to point W. So from here to here, we need to figure out how many units we gotta go up. So 1, 2, 3, 4, 5, 6. So if I'm dealing with a bisector, I'll just cut it in half. So in here, if I divide 6 by 2, it gives me 3 units. So basically, the midpoint is going to be 3 units away from either one of these points. So from X, if I count 1, 2, 3, it's at this level right there. Just a second. So it'll be right over there. And then I also need to find the midpoint, the horizontal midpoint. From X to W, how many units should I go to the left to get to the other point? So it is, let's see, 1, 2, 3, 4. Cut it in half. So it's 2 units right there. So basically, if I go up 3, left 2, I'll find the midpoint. So go from point X, go up 3 right here, and then left 2. So the midpoint is going to be right there. So I need a line passing through that point. It's also going to be perpendicular 90 degrees to the original line. So it is going to look like something like that. It's not going to be the perfect one, but that's how it's going to look like. So basically, the line is going to pass through. What's the y-intercept of that blue line? The point of intersection between the blue line and the y-intercept. So that point is -1. Right here, the y-intercept, when we write the slope-intercept form, b stands for the y-intercept, which right here is equal to -1. So the equation I need is going to look like y equals, I don't know what the slope is going to be, but I know that the b is going to be -1 in the end. So if I just scroll down and see how many -1s in the end I have, I might as well end up with my answer. So let's just, okay, there's only one -1. The other one is -3, but the blue line is not going to pass through -3. It is not going to pass through +1 or +1. So I know that the answer is going to be A for sure, but let's just complete the question, because I don't know if you're going to have more than one option when you do your questions. But what we do for the rest is figuring out the slope of the original line and then using that to find the slope of the blue one. So the original slope, let's talk about that one. Right here, its slope equals to, just pick 2 points. One of them is already picked, or yeah, one of them is already picked over here. And then the other one is, let's just use this right there. Slope is rise over run, right? From one point to the other, find the rise. So let's change that color. From this point to the other one, if I go up 1, 2, 3, up 3, and over 1, 2 to the left. Since it is left, I need to put -2. So the slope is -3/2. Instead of using that negative for 2, which doesn't change anything, I just know that probably you're not familiar with that, putting that negative into the denominator. So I'll just do this, -3/2. That's the slope of the original line. So again, in the other question that we just had, I just said that if two lines are perpendicular, their slopes are going to be negative reciprocal, right? Basically flip it and then change the sign. So the slope of that second line is going to be the one that I need. Its slope is going to be, flip that 3/2, turn it into 2/3, and then instead of a negative sign, have a positive sign, or just don't have any sign. It's the same thing as putting plus. So 2/3 times x minus 1. That's how we figure it out. Basically, this is going to be our answer. Again, you're going to use the properties like if two lines are parallel, their slopes are equal. If two lines are perpendicular, their slopes are negative reciprocal. And then the word bisector means cut it in half, find the vertical and horizontal distance, and then divide those numbers by 2 to find the midpoint. Okay, right here. What is the slope of a line perpendicular to line Q? This one is easier, much less work. So you need the slope of a second line that is not visible over here. This is line Q. We need a line that is perpendicular to this green one. So first find the slope of this one here and then flip it since it says perpendicular and change the sign. Okay, so the slope of this one here is, we have already 2 points on the graph. So from L to K, if you go up 2, that's our rise. M is rise over run. Rise is 2. Run is 2, 4, 6 to the left, which means you need a -6. And then simplify that number. 2 and 6, 2 and -6 are divisible by 2. That would be equal to 1/3. But then again, I don't want to put that negative in front of 6, even though it doesn't change anything. I just want to put it in front of my fraction. So -1/3 is the slope of the green line. So if I have a second line that I don't see over here, and if I want to find the slope of that line that is perpendicular to the green one, what I need to do is flip that fraction and turn it into 3/1, and then change that sign from negative to positive. So this would be the slope. 3/1 and 3 is the same. That would be my slope. again, when you deal with perpendicular lines, you flip it and change the sign. You flip the slope and change its sign. Which of the following graphs represent a line perpendicular to whatever is given over here? So I'll just write it first over here because I need to scroll down to see all four graphs. Y equals negative 3 over 2 times x plus 3. Again, we need to understand what you're talking about. Is this equation given at the top represents one of the four graphs? Is that what this question is about? Which of the following graphs represents a line perpendicular to the given one? So neither one of these graphs should belong to whatever is given at the top. They should belong, one of them should belong to a line that is perpendicular to the given one. So if the slope of this given one is negative 3 over 2, the slope of the perpendicular one should be, let's just put perpendicular slope, even though that doesn't mean anything, but I know you understand. So perpendicular slope, the slope of the perpendicular line is going to be flipped at negative 3 over 2 and turn it into 2 over 3 and then change that negative into positive. So this is what I need. The slope of one of these lines should be 2 over 3. And then what that means,
today is Tuesday, May.
Okay, sorry for that interruption. So what we do again in here, the slope I'm looking for is 2 over 3. What that means is when I pick 2 points on the line, it should be up to right 3. Up to right 3. Because this is the rise, and that number represents the run. Rise 2 units, run 3 units to the right. So when you have a positive slope, I know as a teacher that the line from left to right should rise. So this one, the first one here, is going down. This is negative slope. I don't need this. I don't even want to look at that because again, from the left to the right, it goes down. That means the slope is negative. Okay, so I don't want to look at that one. This one here at the upper right corner, it's rising from left to right, it goes up. So this could be the answer that I'm looking for. Now let's just see when I pick 2 points like this one here and that one here. Is it up to right 3? If so, that's going to be my answer. So from the first point to the second one, I go up 2 and then right 3. So this looks like my answer. So the slopes are going to be perpendicular. That's my answer. That must be my answer. So I'm scrolling down and then to see if there is, okay, like look at this one here. I'm just going to put that point on. This is not up to right 1. My bad. That's up to right 1, which I don't need. Right here is my answer. This over here is up to right 1. That's not what I need. And then the y is a negative slope anyways. So again, my answer is going to be the upper right one, the x. So x is going to be the answer to this. Let's move on to the next one. And this question is going to be, let's not do that right now. There is a formula for this. I don't want you to memorize. If you look up, let me see, line ratio formula, you can figure that out. All you have to do is plugging numbers in, which I really don't want to do right now. I want to talk about conceptual understanding of these questions. Same thing applies to question number 6. Okay, let's do this one here. This is going to be the last question for the day. Okay, determine the exact slope of each of the lines. Line P and Q are parallel. So these two, so if P and Q are parallel, okay, if these two are parallel, what that does is slope of line P and slope of line Q is going to be equal. So MP and MQ are going to be equal, these two. Basically, these two are going to be the same. Let's just set them up equal and solve it. So 2x plus 1 divided by x plus 3 equals 8x minus 2 over 2x plus 6. So what I will do first is, okay, I see that, which is going to make the question much easier, so I'll go with it. So if you look at the denominators, one of the denominators over here is x plus 3. This one here is 2x plus 6. So there is a relationship between them. If you multiply this one by 2 and that 3 by 2, basically multiply the whole fraction on the left by 2. Multiply right here and then right there. You can do that. Here's an example. If you have 1/3 and if you multiply the denominator by 2 and the numerator by 2, its value is still going to be 1/3. So basically, the fraction on the left, if I multiply the bottom by 2, multiply the top by 2, the value of the fraction on the left side is going to be the same. So I'll explain why I'm doing this in a moment. 2 times 2 is 4x. 2 times 1 is positive 2, divided by 2 times x is 2x. 2 times 3 is 6. And then keep that right side the same. So the reason I did this is so that I end up with the same denominator. Because if that happens, so let me just put this as an example over here. Let's say you have 1/4 equals x over 4. 1 over 4 equals x over 4. So when you have the denominators being equal, you just ignore them. And then just ignore the 4's and then say that 1 equals x. That's how you solve it. It's much simpler if the denominators are equal. So in here, 2x plus 6 and 2x plus 6, it was a minus. Since they're equal, you can just ignore them and then set the rest of the equation up. So 4x plus 2, drop the equal, drop the right side, and then put the x's together. So I want to get rid of this 4x by doing its opposite, which is subtraction, since it was positive. Drop the 2, it is positive. 8 minus 4 is 4x minus 2. So since I have my variable on the right side, I want to get rid of the negative 2 by doing its inverse, positive 2 to each side. Right becomes 4x, left is 4. Divide everything by 4 to get the x by itself. So x equals to 1. So it says determine the exact slope of each line. Once you have this, you don't need to do anything else. Plug it in. So for in here, plug in 1 for x and 1 for x, 1 for x. That's all you need. For p, for the first fraction, it is going to become 2 times 1, that's 2, plus 1 divided by 1 plus 3. So if you add the top, 3 over 4 is the slope of line P. We know that P and Q are parallel, right? That means their slopes are equal. So Q will have the same slope. You don't need to plug it in and then calculate it. And then since R is perpendicular to the other two lines, it is going to be flip the fraction, change the sign. The original sign was positive, flip it to negative. And then that's all you need. So that was all for this video. Sorry that it took a while, but the lesson is a little hard, and then I wanted to cover all of the different types of examples other than just plugging in numbers into a formula. So thanks for watching. Comment below if the video helped you out or if you have any questions, and I will see you in another video.